everybody. I am going to spend some time going through the Unit 2 Trigonometry review with you so that you are ready for our unit test on trig. The first couple of problems deal with conversions from radians to degrees and degrees to radians. One of the things you want to remember is that your final answer has to be positive, and the value of your angle must either be between 0 and 2 pi if you're dealing in radians, or between 0 and 360 degrees if you're dealing with degrees. On the test, it'll basically say that your answer has to be written so that it's within one complete revolution around the unit circle. And so basically that's what that means. So let's just remember that when we're going from degrees to radians, radians usually have a pi in it, unless it's been multiplied through. But in this case, if I want to change from degrees to radians, then I need to introduce pi. So we're either looking at multiplying by pi over 180 or by 180 over pi. Since I'm in degree mode in number 1, I've got 255 degrees. And that number itself is within one full revolution on the unit circle, so I don't need to change anything. But if I want to convert it to radians, I need to introduce a pi. So I'm going to multiply by pi over 180, because technically the value of pi is equivalent to 180 degrees. And so I'm really just multiplying by 1, because if pi and 180 degrees are the same quantity, then I'm just multiplying by 1, and I'm not really changing the value of my expression. I'm just changing the way it looks. And so when you multiply by pi over 180 degrees, your degree values cancel, and we don't usually show that step. But then you're left with 255 times pi over 180. The easiest way to evaluate this on your calculator is to ignore the pi and just type in, let me clean that up. So it's just going to basically be 255. Since 180 is in the denominator, I'm dividing. And I want to make sure that my final answer is also left in radians, or in a fraction form. So when I change my answer back to a fraction, the calculator will give it to me. And it's 17 over 12. Now don't forget that you have a pi here. So it's actually going to be 17 pi over 12. All right, in number 2, notice that our degree here is 712 degrees. That hopefully should send a signal to you that that number is way too big. So because it's already starting off beyond our unit circle, since it's more than 360 degrees, to get this degree back onto the unit circle, I'm just going to subtract away 360 degrees. And we're going to keep doing it until we land back on the unit circle. So if we have 712 and I'm subtracting 360, that's going to give me 352 degrees. And 352 degrees is on my one revolution of the circle, since it's less than 360. And now I'll go ahead and do my multiplying by pi over 180. And again, your degrees are going to cancel. And so when you take 352, you're basically dividing by 180 and then converting it back into a fraction. And you'll get 88 over 45, but you got to remember that's 88 pi over 45. And in number 3, we've got a negative angle now. We have negative 140 degrees, so the way I get that back onto the unit circle is by adding 360. So if it's too small, we add a full circle, and that'll put us where we need to go. And again, you can do this right on the calculator. You've got negative 140 plus 360, and that gives us 220 degrees. And if I multiply that by pi over 180, again, those degrees are going to cancel, and I essentially want to take 220 and divide it by 180 and convert that into a fraction. And that's going to give me 11 over 9, but don't forget it needs to be 11 pi over 9 because we didn't take pi into an account. Okay, in the second set of problems, now we're starting off in radians, and you can tell because there's a pi, and we need to convert it into degrees. So this time I'm still going to multiply by the fraction with the pi and the 180, but this time I'm going to flip it over because it's the pi that I need to get rid of. So if I take 9 pi over 4, I can multiply that by 180 degrees over pi, and this time my pi's are going to cancel. When dealing with radians, sometimes it's hard to tell if your radian measure is over 2 pi or not. And so it's easier just to go ahead and do the conversions and then take your final answer and add the 360 or subtract the 360 to get it where it needs to be. because it will show, like, the 9 pi over 4, if you think about that, that's going to be over 2 pi. So my final answer is going to be too big. It's going to be over 360 degrees, and I'm going to have to subtract away. But it's not always easy to tell when it's written in radian form. So do the multiplication first. Your pi's are going to cancel this time. And so on the calculator this time, I'm going to multiply 9 times 180. And then since the 4 is in the denominator, I'm going to divide by 4, and I'm going to get 405. This time my answer is going to be in degrees. But remember, that's too big, so I'm going to need to just subtract 360, and that's going to leave me with a 45-degree angle. All right, in number 5, we're going to do the same thing. I'm going to multiply by 180 degrees over pi. My pi's cancel. And again, with our calculator, we can just take 11 times 180 and divide that by 6. And our answer is 330 degrees. And since that is less than 360, we are good to go. In number 6, I've got negative 13 pi over 8. Again, I'm going to multiply that by 180 degrees over pi. The pi's cancel. Now just be careful when you're multiplying because you want to include the negative. So it's going to be negative 13 times 180 divided by 8. And that's going to give me a negative 292.5. And that is in degrees. But obviously, since that value is negative, we're going to need to add 360 to that. You can do that on a calculator. And that gives us 67.5 degrees. And we can leave our answer just like that. Okay. In the next set of problems, we're dealing with arc length. And it is expected that you have this formula memorized, that the arc length for a circle, or for a sector of a circle, is equal to theta times the radius, where theta is measured in radians. So you do need to make sure that if you're given a theta value in degrees, that the first thing you do is convert it to radians. So let's take a look at number 7. Determine the arc length of a sector with a radius of 26 inches and a central angle of 144 degrees. So I know that my radius is 26 inches. That's great. But my theta value, notice, is in degrees. So the very first thing I'm going to need to do is convert it to radians. Since I need a pi, I'm going to multiply by pi over 180. Those degrees are going to cancel. And we can do what we did in the last section and simply take 144 divided by 180 and then convert it back into a fraction. And that's going to give us 4/5. So that means that my theta value is actually 4 pi over 5. Okay, and the theta is in radians, so it's not in inches or anything like that because that's just the measure of the angle. So if I want to find the arc length, remember, is S. And according to our formula, I'm basically going to take theta, which is 4 pi over 5, and I want to multiply that by my radius, which is 26. Now, on your when you're simplifying, again, if you want, you can write the whole answer using a decimal, and you'd actually multiply 4 pi times 26 and divide it by 5. But I think on the test, we leave the pi out. So you're just going to do 4 times 26 and then divide that by 5. And again, I've just been leaving everything as a fraction. So if you convert it back into a fraction, you'll have 104 over 5. You will need to remember, though, that there is a pi in that. So it's going to be 104 pi over 5. And because we're dealing with the length, it's actually a measure. It's the distance around the sector. Since the radius is measured in inches, I also want to label the arc length in inches. Now, if you wanted to write it as a decimal, you could basically 104 times pi divided by 5, and this would give you your decimal approximation. I do think on the test, though, it's written as a fraction, and so I'd encourage you to leave it as such. Okay, in number 8, it says, suppose a sector has a central angle of 4 pi over 5. Well, that's great. It's in radians. I'm actually going to write that down. And interestingly enough, it's the same measure as the one above it. But this time, we're also given the arc length. The arc length is 8 pi over 15 centimeters. So arc length is our S. So we're given the S value of 8 pi over 15, and that's in centimeters. And we're asked to determine the length of the diameter. Okay, well, if you think about your formula doesn't have the diameter in it. It's the arc length is equal to theta times r. So I'm going to figure out r first, and then once we know the radius, we can figure out the diameter from that. So if our formula is s equals theta times r, let's fill in what we know. I know that my s is going to be 8 pi over 15, and I know theta is going to be 4 pi over 5. What we don't know is r. So if I wanted to solve for r, if you think about it, if you have 4 equals 2x, the way you solve is by dividing by 2. And so that gives you x equals 2. So I'm going to do the same thing here. I can just divide both sides by 4 pi over 5. The problem with that is then you have a compound fraction. So another way of dividing fractions is to multiply by the reciprocal. And since it's this quantity that I'm trying to get rid of, if I multiply by the reciprocal, 5 over 4 pi, remember whatever I do to one side, I'm going to have to do to the other. Then I know these 5s are going to cancel and my 4 pi's are going to cancel. So the only thing I'm going to have on the right side is the radius. And then if you take a look at the quantity that's on the left-hand side now, you can either use your calculator to simplify this or you could start canceling. The one thing I noticed right away, though, is that the pi's cancel. And then if you want to do this on the calculator, just be very, very careful because you've got a couple things going on. You've got 5 times 8 in the numerator and you've got 4 times 15 in the denominator. So make sure you put parentheses around it. So I'm going to do 5 times 8 in the numerator, and then when I divide, I don't want to just divide by 14, or I'm sorry, divide by 4 and then divide by 15 again. I actually want to write it as a quantity, 4 times 15. Otherwise, you'll get a different answer. You want to use your order of operations. And so when I simplify that, we get 0.6666666. So you can either leave it as a decimal, or again, you can change it back into a fraction. And that gives me a radius of 2/3. And you do need to be careful. That's going to be 2/3. And then since the units of measure are centimeters, that gives me 2/3 centimeters. Now, we're not asked to find the radius. We're asked to find the diameter. So you do need to remember the ratio or the relationship between the radius and the diameter is that the diameter is twice the radius. So that means that my diameter is going to be 2 times 2/3 centimeters. And this is just 2 over 1, and so that means that my diameter is actually going to be 4/3 centimeters. Okay. In number 9, I don't know if you guys have ever been to Ocean City and ever ordered a Captain's Pizza, but they are the most gigantic pizza slices I have ever seen. And so when we started this unit, I immediately thought of Captain's Pizza in Ocean City. They're 28 inches in diameter. That's huge. It's over 2 feet wide. And the slices, you get 16 slices per pizza. And so what we're asked to do here is to eventually find the arc length of each slice. So serving Ocean City since 1975, Captain's Pizza is more than just a pizza joint with subs, wings, salads, pasta, and desserts. They have the largest pizza in town with a diameter of 26 inches and 16 slices. So if you split a pizza, which is 360 degrees, into 16 equal slices, then what would be the central angle of each slice? So let's try that. That's going to give us our theta value. So if we have 360 degrees and I divide it into 16 slices, well, let's go ahead and figure that out. 360 divided by 16, that gives us 22.5 degrees. And since eventually in part B, we're actually asked to determine the arc length, at this time, I'm just going to go ahead and figure out the equivalent radians for this quantity. So 22.5 degrees, if I multiply that by by pi over 180 degrees, I know the degrees are going to cancel. And then on my calculator, I can just take my 22.5 and divide it by 180. And I am going to go ahead and rewrite that as a fraction. And that gives me 1/8, or pi over 8. So that would be the interior angle of each slice. And then in part B, it says to use this given information and your answer in part A to determine the arc length of each slice of Captain's Pizza. So if you think about it, let me actually do this in a darker slice. So there it's sliced into quarters. If I slice it again, that's going to give me 1/8, and then if I slice it again, That should be 16. I don't know if I counted right, but that should be 16 slices. It's a little distorted on here. But we basically just figured out that this angle right here is pi over 8. And if you think about the formula that we need to determine the arc length, so the arc length is basically the length of the crust of this pizza. The only other measure I need would be the radius. So if I know that the diameter is 28, then I know that the radius must be 28 over 2, or 14 inches. Let me scroll up a little bit more so we have some space. Okay, so now I have everything I need to find the arc length. I know that my arc length is going to be theta times r, and since I know theta in this case is pi over 8, and my r value is 14, when I simplify that, and in this case I actually am interested in knowing how wide this slice is. So I'll show you how to calculate it in terms of pi. That's basically going to be 14 divided by 8. And if you want to write it as a fraction, you can keep it as a fraction. It'll just simplify that for you. It'll be 7 pi over 4, and that's in inches. However, that's hard for me to kind of approximate what that actually means. And so with a real life problem like this, if I want to know the length of the crust of a piece of pizza, it's going to make more sense for me to actually multiply this all the way through. So if I actually take 7 times pi and divide it by 4, I get about 5.5 inches. So each slice, when you think about the crust, is about 5.5 inches. So you can imagine how big those slices are. They're huge. I mean, one slice is enough. Anyway, that's my plug for Captain's Pizza in Ocean City, Maryland. All right, in the next section, you're basically asked to determine the point xy on the unit circle that corresponds to the given central angle theta. If the value of theta is not a common angle on the unit circle, then use your calculator. So if you think about theta is equal to 2 pi over 3, that is an angle on my unit circle. If you think about your unit circle, this is pi over 6, pi over 4, pi over 3, pi over 2. So this angle right here is my 2 pi over 3. And what you should recognize is the x value is going to be negative and the y value is going to be positive. And it's going to correspond to a negative 1/2 and a positive square root of 3 over 2. Sorry, I probably should write this down here. You will have a unit circle to use on the unit test. We've already assessed your ability to reconstruct the unit circle on your own, so you will not have to memorize it. I mean, you should have it memorized, but you don't have to have it memorized for the unit test. We'll provide you with a unit circle on that, so you should be able to get that okay. In number 11, this time we're dealing with an angle of negative 45 degrees. So you do need to remember that when an angle is negative, if the x-axis, if this is our standard position, if I'm going to go in a negative direction, that means I'm going backwards. I'm going clockwise. And a 45-degree angle, this would be a positive 45-degree angle. So a negative 45-degree angle is going to put me down here in the 4th quadrant. And that's going to be the square root of 2 over 2 and negative square root of 2 over 2. Okay, if you're not comfortable with that, you can certainly add 360 to that, and then that'll help you figure out the coordinates of the point. But I think it's easier if you just go down. So like if I added 360 to this, let's do that on our calculator. So if we have a negative 45 and we add 360, that's going to put me at 315 degrees on the unit circle. And so if you look for 315 degrees, that's this angle as well. So you'll end up in the same place either way you do the problem. But the answer is going to be the square root of 2 over 2 and negative square root of 2 over 2. All right, and number 12, 50 degrees. Well, 50 degrees is not on your unit circle. So if you want to figure out the coordinates that are associated with 50 degrees, you're going to have to do this on the calculator. Because we're dealing with degrees, I want to make sure that my mode on my calculator is set to degrees. So it's not, I'm going to need to change it. And if I want to find the ordered pair, we're used to writing our ordered pair in the form xy. But in terms of our trig functions, remember x is going to correspond to the cosine of theta, and y is going to correspond to the sine of theta. So if I'm finding this ordered pair, if I want to find the cosine, again, I'm going to make sure that I'm in degree mode. I'm going to do the cosine of 50 degrees. And it's in degree mode, so I don't have to do anything else. And that gives me a value of 0.643 about. And then I'm going to do the same thing to figure out the value of y, or the sine. So I'm going to do the sine of 50, and that's going to give me about 0.766. Okay. And just a reminder, if you're told that the angle is a reference angle, in this case, we're told that it's a central angle. So wherever we are in the unit circle, that's what we're going to write. But remember, if it's a reference angle, we're looking at all of the values. So it's going to be a plus or minus x and a plus or minus y. So you're thinking about the 4 different points on the unit circle that would have the same reference angle. And so that basically means the true value of x and y are going to be the same, but the signs may be a little bit different depending on what quadrant you're in. All right. In numbers 13 and 14, you're basically asked to evaluate, and 15 too, I guess, you're asked to evaluate the function for the given value of theta. So what I recommend doing, so if we have theta is equal to 5 pi over 6, 5 pi over 6 is on your unit circle. It's actually, if I were to draw a picture, 5 pi over 6 is right here. Okay, and my recommendation when you're doing these problems is to actually write the ordered pair down. And so that's going to correspond to a negative square root of 3 over 2 and a positive 1/2. And remember, this is your x, this is your y. When you're asked to find the sine of theta, then you're basically being asked, what is the sine of 5 pi over 6? Well, sine corresponds to y, and so the y value is 1/2. The cosine corresponds to your x-coordinate, and that's going to be negative square root of 3 over 2. If you're asked to find the secant, well, you've got to remember the relationship between the secant and the cosine. It's basically going to be the flip side, or the reciprocal. So you don't have to write it as 1 over negative square root of 3 over 2. You can essentially just flip your x value. So that's going to leave me with negative 2 over the square root of 3. It doesn't matter where you put the negative, as long as the fraction is negative. Now, on the unit test, you can actually just round this to a decimal. So you can actually just take negative 2 divided by the square root of, oops, I can't see. Take that and divide it by the square root of 3, and that'll give you the decimal equivalent. Or if you need to, you can rationalize this. So I know in the end it's going to be, what did I say was a negative, oops, negative 1.15. So I know that's what it's supposed to be. Traditionally, though, we like to be as exact as possible. And so if I wanted to leave this in simplest form, I'm not allowed to have the square root of 3 in the denominator. And so we rationalize. Oops, I don't know what happened there. So by rationalizing, I'm basically multiplying this fraction by 1, except it doesn't look like 1. I'm multiplying by the square root of 3 over the square root of 3. On top, that's going to leave me with negative 2 times the square root of 3. But on the bottom, when I multiply the square root of 3 by itself, I end up with the square root of 9, and the square root of 9 is just 3. And so that's called rationalizing. And if you want to double check to make sure you did it right, I can take negative 2 times the square root of 3, and then I can also divide that by 3, and I should end up with the same value. Okay, so the cotangent, remember, is basically the cosine over the sine, or x over y. And so if I look at my x value, that's going to be negative square root of 3 over 2, and if I'm dividing that by 1/2, now that's a compound fraction. And a lot of you guys freak out when you see fractions to begin with, so when you see a fraction over a fraction, it just makes it even worse. Well, this is just division. You guys actually learned how to divide fractions in elementary school. You're basically going to take that top fraction, negative square root of 3 over 2, and instead of dividing, you're going to multiply by the reciprocal of the denominator. And the reciprocal, remember, just means flip it. So if you're dividing by 1/2, that's the same thing as multiplying by 2 over 1. And conveniently, our 2's cancel, and we're left with negative square root of 3 over 1, or just negative square root of 3. Okay. In number 14, now we've got theta is equal to negative 3 pi over 2. So if I think about my unit circle, I know that a positive 3 pi over 2 is here. It's basically at 270 degrees. So a negative 3 pi over 2 means I'm going the same distance but in the different direction. So I'm going 3/4 around the unit circle, but I'm going clockwise instead. And so that means that I am going to be at pi over 2. And the coordinates of this point are going to be 0 and 1. So actually this is kind of nice because it's going to be a little bit easier to evaluate. So remember, this is our x value, this is our y value. Cosine corresponds to x, and so that means my cosine is 0. Tangent this time is y over x, and so that means I'm going to do 1 over 0. But please try this on your calculator, because what I'm finding is that anytime people see a 0, they think the answer is going to be 0. But if you try to evaluate this on your calculator, 1 divided by 0, your calculator gives you an error message. You are not allowed to divide by 0, meaning 0 is not allowed in the denominator. And so you're just going to write undefined, or you can abbreviate if you want. But that does not cancel to 0. The secant, remember, is related to the cosine. It is the reciprocal of it, so it's just going to be 1 over x, or simply flip x. Well, notice x isn't a fraction, so if I put a 1 underneath it, then it becomes a fraction, and when I flip it, I'm left with where I was above, which is 1 over 0, which we already decided was undefined. The cotangent is basically the flip of the tangent, or x over y. And so x over y means that it's 0 over 1. Now please recognize the difference between 0 over 1 and 1 over 0. If I have nothing and I split it with one person, that person gets nothing. And if that doesn't make sense, do 0 divided by 1 on your calculator. Okay, so 0 divided by 1 is okay. It's 1 divided by 0. If you have $1, like if we're looking at this, if you have $1 and you split it among 0 people, you're basically trying to make that dollar disappear. And even though I'm quite good at that, that is not something that is possible mathematically. So that's why it's undefined. All right, in number 15, now you're given a measure of an angle that is in degrees. And if you notice, 405 degrees is outside of 1 revolution of the unit circle. So I'm going to go ahead and subtract 360. And if we subtract 360, that gives us 45 degrees. And at 45 degrees, that puts me right there. And the coordinates of that point are going to be the square root of 2 over 2 and the square root of 2 over 2. And so again, this is x, this is y. When I'm asked to find the sine, that's y, so that's just going to be the square root of 2 over 2. The cosecant now is the flip of y, or the flip of the sine. It's the reciprocal of the sine. So instead of doing 1 over the square root of 2 over 2, I'm just going to flip it. So that's going to be 2 over the square root of 2. But I'm not allowed to have that square root in the denominator, so when I rationalize, I multiply by the square root of 2 over the square root of 2, because that's essentially 1. And then I multiply across. And so I get 2 times the square root of 2. And then in the denominator, the square root of 2 times the square root of 2 gives me the square root of 4, which is 2. Now the other thing I notice is that I have 2 2's that can cancel, and so my final answer is simply the square root of 2. The secant of theta is just going to be the flip of x, which is basically the same as the cosecant, since x and y are the same in this case. So I know that's just going to be the square root of 2 as well. The cotangent is going to be x over y. And so that's going to be the square root of 2 over 2 divided by itself. Sorry, I'm running out of space here. And hopefully you guys can see right away that when you divide something by itself, it should just be 1. If you don't see that, then multiply by the reciprocal. It'll be the square root of 2 over 2 times, and then I'm going to flip my denominator, 2 over the square root of 2. Everything cancels to 1. Remember that when you're multiplying or dividing and everything cancels, they cancel to 1. Okay. In the next set of problems. So these are the problems that involve constraints. It's almost like you have to be a detective. You're given some clues. You're not told what theta is. In fact, you're never going to know what theta is. You're just going to kind of try to figure out what quadrant it lies in and then use the other pieces of given information to evaluate the functions. So let's first practice on identifying the quadrant where theta lies. So in number 16, basically you're told that the tangent is negative and the sine is negative. That's what less than 0 means. Tangent and sine are both negative. And if you remember, let me go ahead and do this thing over here. If you remember, in our unit circle, we have quadrant 1, quadrant 2, quadrant 3 and quadrant 4. And we had a nice little acronym that we remembered, or hopefully we remembered. We said all students take cash. And that may not have been exactly how I refer to it, but we'll just think of it that way. All students take cash. And the reason that we wrote these numbers or wrote these letters is because in quadrant 1, all functions are positive. In quadrant 2, the S refers to the sign and also its reciprocal, which would be the cosecant. And in quadrant 3, we're referring to the tangent as well as its reciprocal. And in quadrant 4, we're referring to the cosine as well as its reciprocal, which is the secant. And then basically everything else is going to be negative. So there's nothing negative in quadrant 1. But in quadrant 2, that means that the tangent is negative, the cotangent is negative, the cosine and the secant are all negative in quadrant 2. In quadrant 3, that means that it's going to be the cosine, the secant, the sine, and the cosecant are all negative. In quadrant 4, it's going to be the sine, the cosecant, tangent, and cotangent are all negative. So it's important to remember that acronym because it's going to help you when you're trying to identify the quadrants in these problems. So in number 16, it says the tangent is negative. So I'm going to just narrow this down. The tangent is negative. I'm going to actually draw a little grid here. So the tangent is negative only in quadrants 2 and 4. And then I'm also looking at where the sign is negative. Well, the sign is negative in quadrants 3 and 4. And so where they overlap is quadrant 4. And that's what I'm looking at, where they overlap. In number 17, again, I'm going to do this. The cosine is greater than 0, meaning the cosine is positive. So that means I'm either in quadrant 1 or quadrant 4. Excuse me. We're also told this time that theta is between 3 pi over 2 and 2 pi. Well, think about where that is. 3 pi over 2 is here at 270 degrees, and 2 pi is here. So that narrows it down to quadrant 4 again. In number 18, we're told that the secant is negative. So if I look at my little chart, the secant is going to be negative and the secant, remember, corresponds to the cosine. So when is the cosine negative? It's going to be negative in quadrants 2 and 3. We're also told that theta is between 0 and pi. So between 0 and pi is these two quadrants. And so where do they overlap? They overlap in quadrant 2. And finally, in number 19, we're told that the sign is greater than 0. That means the sign is positive. So that's in quadrants 1 or 2. But then we're also told that theta is between pi over 2 and 3 pi over 2. And so those overlap in quadrant 2. And so that's helpful because in the next two problems, we actually have to use that information to draw a triangle, and then we're going to be relying on Sohcahtoa to help us with evaluating the trig functions because we're not actually going to know the value of theta. So in number 20, we're told that the cosine of theta is equal to negative 4/5. So that tells me that the cosine is negative. Also, I'm told that it lies in quadrant 3. So what I'm going to actually do is physically draw a triangle in quadrant 3. And so I always draw my hypotenuse out from the origin, and I always draw my altitude either up or down to the x-axis. And then my theta is always intersecting with the origin. And so if you think about Sohcahtoa, with Sohcahtoa, in fact, if you want to write it down on another sheet of paper, can actually put it in here. So if we have Sohcahtoa, now it is expected that you guys have this memorized from geometry and that you can reconstruct this. So this is not something that we're going to do for you on the unit test. You need to know Sohcahtoa. So if you remember that basically tells you that the sine of theta is equal to the opposite over the hypotenuse, that the cosine of theta is equal to the adjacent over the hypotenuse, and that the tangent of theta is equal to the opposite over the adjacent. And if it would help, you could also write all your reciprocal formulas. Remember, sine goes with cosecant. And cosecant is basically going to be the flip. It's going to be the hypotenuse over the opposite. Cosine goes along with secant, and it's going to be the flip. It's going to be the hypotenuse over the adjacent. And then the cotangent, when I flip the tangent, it's just going to be adjacent over opposite. The one thing you do need to remember is that your hypotenuse is always, always positive. And then the sign of your opposite and your adjacent sides is going to depend on what quadrant you're in. So with the cosine in number 20, remember that means that this is the adjacent side over the hypotenuse. And since this value is negative, I've got to figure out, well, am I going to use it as a -4 or a -5? There's only one negative, so both numbers aren't negative. So I know that the hypotenuse must be positive, so I'm going to go ahead and label that with a +5. That means that my adjacent side has to be -4. And if you think about it, that makes sense. I'm in the third quadrant, so the x value has to be negative. I'm also sure that since I'm in the third quadrant, the y value also has to be negative. So that's another thing to keep in mind is even though it's not listed, you'll have to recognize that the opposite side is also negative in the third quadrant. And then you've got to figure out what the length of that side is. Well, some of you guys may already recognize the pattern, but if I think of this as A and this is B and this is C, then I know that A squared plus, now when you're using the Pythagorean theorem, you're talking about the length of the sides of a triangle, so don't put your negatives in there. Okay, and so we basically get that a squared plus 16 is equal to 25, or a squared is equal to 9, so that means that a must be 3. But please remember, since it's in quadrant 3, that value must be negative. So if I want to figure out the sign, well, we know with Sohcahtoa, that means it's going to be the opposite over the hypotenuse, so that's going to leave me with -3/5. The tangent, that's TOA, that's going to be opposite over adjacent. So -3 over -4, those negatives cancel and we'll be left with a +3/4. The secant, let's just look real fast. The secant we said is going to be the hypotenuse over the adjacent. So hypotenuse over adjacent. So my hypotenuse is 5, the adjacent side is -4. And so that's the same thing as -5/4. You can pull the negative out in front. The cotangent is essentially the flip of the tangent, or you can go back to using the adjacent over the opposite if you want. But because I know the relationship between cotangent and tangent is that they're reciprocals, I know that my cotangent must be 4/3. The last thing you might want to check is that your signs match what they're supposed to. So for example, since I'm in quadrant 3, that's what quadrant I'm in right now, I know that my cosine value has to be negative, my secant has to be negative, and notice it is, so I'm looking at my secant, and my answer to the secant is negative, so that works. My sine value has to be negative, and so notice that my sine value is negative. The tangent and the cotangent both have to be positive, and so when I look at my answer to tangent and cotangent, both of those values are positive. So that's a nice way to just kind of double check to make sure that the signs are correct. And that way, if you've drawn your triangle wrong, at least you can back up and put the correct signs in at the end. Okay, in number 21, you're basically given that the cotangent this time is equal to -3/2. And just a reminder, the cotangent is the adjacent over the opposite. Let me write that down. Let me actually give myself a little bit more space. So this is going to be adjacent, and this is going to be opposite. Actually, let's do this so you can see it. Okay, and so since the cosine is negative and the cotangent is negative, I'm trying to figure out what quadrant both of those things are true. So I know that the cotangent is negative is going to be in quadrants 3 and 4, and if the cosine is also negative, then I know I'm basically dealing in quadrant 2. So when I draw my triangle, I'm going to draw it in quadrant 2. And so remember, your hypotenuse always comes out of the origin, and you always drop your altitude to the x-axis. So this is theta. All right, in this case, the adjacent side has to be 3. And because I'm in the second quadrant, I know that the negative must be going with the 3. And then my opposite side is going to be 2. And because I'm in the second quadrant, I know that my 2 has to be positive because the y value must be positive. So now I've got to figure out the hypotenuse. And again, we're just going to use the Pythagorean theorem. That tells me that 2 squared plus 3 squared, and again, don't put the negative in there. I mean, if you did, it's not a big deal because when you square it, it should still be positive, but that's going to be equal to my hypotenuse squared. So this is 4 plus 9 is equal to c squared, or 13 is equal to c squared. If I take the square root of both sides, I get that c is equal to the square root of 13. And I do believe on the test, you will be able to round this value to a decimal. And so I'll write all my final answers as decimals, if that's helpful. So in number 21, we're dealing with a sine of theta. Well, remember sine, Sohcahtoa, that's going to be opposite, which is 2 over the hypotenuse, which is the square root of 13. So you could rationalize this, but again, I think on the unit test, it's asking you to write that as a decimal. And so essentially, you're just going to take 2 divided by the square root of 13. And that'll give you 0.555, approximately. The cosine is going to be the adjacent over the hypotenuse, which is going to be negative 3 over the square root of 13. And so again, if we do this on the calculator, negative 3 divided by the square root of 13, and that's going to give me negative 0.832. The tangent, TOA, that's going to be opposite over adjacent. And that's negative 2/3. If you want to rewrite that as a decimal, that would just be negative 0.667. The cosecant, remember, is just going to be the reciprocal of the sine. And since we already figured out the sine, I would write that as the square root of 13 over 2. And if we want to find the decimal equivalent, we're going to take the square root of 13. Please make sure you close the parentheses before you divide by 2. And that's going to give you 1.803. And that's how you do those types of problems. Okay. All right. The next types of problems get us into graphing and using graphs to solve problems. So in number 22, basically you're given a wave pattern and you're asked to determine equations that can model this wave pattern. There's actually an infinite number of equations that I could use to model this pattern, but because I'm designating where I want the cycle to start, that's what the A, B, C, and D represents, there will be a unique equation corresponding to each of those values. So one of the things that I like to do when I'm looking at these problems is to identify the things that they're all going to have in common. So for example, they're all going to have the same midline. And so if I draw that midline, I know that my midline has to be 2. And that's a k value. So I know that k is 2. That's my midline. I also know that the amplitude for each of these has to be the same. And so if I count from my midline to my max, for example, I know that's 1, 2, 3, 4 units. And so my amplitude, which is the absolute value of A, has to be 4. And that's going to be consistent with all of the different equations. So now what I'm going to do is I'm going to look at each point individually. So if I look at point A, that's where the start of my cycle for this graph is going to begin. And so basically this is my horizontal shift. So I need to identify the h value. Well, I can see right there on the graph that this is negative 7 pi over 3. And what I would recommend doing is just doing this for each of the points and also identifying which curve we're going to use to model it. So since this point starts at the midline, I know I'm dealing with sine. Because it goes up first, I know that I'm dealing with a positive sign. So right next to my little letter A, I'm going to put a plus sign there. So I already kind of know this. And I'm going to do this for all of the points. So the next thing I notice is point B. Now I notice that this is starting at the bottom, and so it's got to be a cosine function if it's not starting in the middle. And since this is starting at the bottom and not the top, I know it's got to be a negative cosine function. So I also need to identify the value of h. The problem is when I look at the axis, there's not a label there. So I've got to figure that out. So if I look back at the way this thing is scaled, if I go from 0 to negative pi over 3, I've got to figure out what's halfway. Well, half of pi over 3 is pi over 6. So each one of these little markers is worth pi over 6. So there's negative 1 pi over 6, negative 2, negative 3, negative 4, negative 5. So this is actually negative 5 pi over 6. In letter C, this one, we're starting at the top. So I know that's got to be a positive cosine. And I know the h value here, again, it's halfway between 0 and pi over 3, so I know h is actually going to be pi over 6. And with letter D, I know that that is starting at the midline, so I know it's got to be sine, but this time it goes down, so it's got to be a negative sign. And the H value for D is 2 pi over 3. Okay. And so now that I've kind of identified all that, I can go ahead and write my equations. And I like to do it this way so that I'm consistent. So for example, in letter A, so what I'm going to do is I'm just going to start off, I'm going to do y equals, y equals, y equals, y equals. I know the A value is going to be 4 for all of them. So I know that I'm going to start off with plus 4 times the sine. In letter B, it's going to be negative 4 times the cosine. In letter C, it's going to be positive 4 times the cosine. And in letter D, it's going to be negative 4 times the sine. And now I'm going to deal with all my quantities. And this is always going to be theta. And it's going to be theta minus h. So if I look at A, my h value is a negative 7 pi over 3, which means I've got to change the sign to a positive 7 pi over 3. In B, it's a negative 5 pi over 6, so I'm going to do plus 5 pi over 6. In C, it's a positive pi over 6, so I'm going to make it negative pi over 6. And then with letter D, it's 2 pi over 3, so I'm going to make that negative 2 pi over 3. Because remember, inside opposite, the h value shifts the graph in the opposite direction, so you do need to change the sign. And then finally, the k value for each of these graphs is the same, so I'm just going to do plus 2, plus 2, plus 2, plus 2, and we are done. So I do think if you have a system like that, it makes it a little bit easier. In number 23, these get us into the modeling problems. So the following equation gives a model for the depth d in feet of the Mississippi River over time in hours. So a couple of things to note here. This value here, that's our midline, that's going to be basically sea level. And then 8, that's basically going to give us our amplitude. We're going to go up and down, up and down, up and down. In letter C, when it asks about the average depth, remember that's basically our midline. The average depth, that would be the maximum plus the minimum divided by 2. So max plus min over 2. Well, that's also how we define, the midline. And so the midline in this case is going to be 156.29, and maybe that's not sea level. Pretend I didn't say that. But the average depth of the Mississippi River is going to be 156.29, and because this is a real-life quantity, I also want to make sure that I use appropriate units. In letter B, it says in order for a barge to travel safely on the Mississippi, the depth of the water must be at least 160 feet. During what time intervals is it safe for the barge to travel the Mississippi? So in this case, I'm going to need to rely on my calculator. So let's make sure that we enter this into our calculator properly. So we type it in. I'm going to do 8 times the sine of 0.5 times t, or x in this case, plus 0.02. Close your parenthesis, and then add 156.29. And if you try to graph it, even if you go to a Zoom 6, you're not going to see much. And that's because, if you remember, for one of the problems, I had to change my mode to degrees. And for all of the application problems, even though you don't see the pi, it's taken into consideration. So like this 0.5 actually was calculated by taking 2 pi and dividing it by the period. So you don't see the pi, but you do need to remember that all of these application problems are in radians. So please change your calculator back to radian mode. The other thing you need to do is set your window appropriately. So you really do have to understand what the variables represent. T in this case is our input. It's going to correspond to our x variable. And we're told that T is measured in hours. And we're looking for the depth of the Mississippi over time. So if I'm dealing in hours, an appropriate domain or time interval, I'm not going to go back in time, so I don't need any negative values. And since I'm dealing with hours, I think 1 full day is an appropriate domain. And so on the test, you're actually going to see questions relating to the domain. And so the domain in this case would be from 0 to 24 hours. That makes the most sense if we talk about 1 full day. Now, the y value is going to correspond to the depth of the Mississippi. Well, I know the average depth is 156.29. I also know that the amplitude is 8, so that means it's going to go up 8 and down 8. So roughly, if I do a rough estimate, I know the highest this thing is going to be is about 164, 165. So again, my y min, I'm just going to keep it at 0, and my y max, I'm just going to go ahead up to 170. And let's see what that looks like. Okay, so I can see that it looks like the depth is at a max twice and at a min twice during the day. And so if the question is asking for what time intervals is there at least 160 feet, 160 feet, that's a depth. So I'm going to need to enter that in as a y value, and I'm going to enter it in as a separate equation. And I can see that it crosses the graph 4 times. Now, if you want to be able to see that a little bit clearer, you could adjust the window a little bit more and make your y max a little bit higher. And I guess we don't really need to have a y minimum of 0. We could make it a little bit bigger, but I think it's okay. Basically, I want to look to see where the curves, where the top of those waves is above the horizontal line. And I can see that it happens twice, but there are 4 points of intersection. I'm actually going to have to figure out each value. So second trace, that'll give me to the menu where I can choose intersect, and I'm going to start all the way over to the left. Oops. If I scoot all the way over to the left and press enter 3 times, please wait until it actually says the word intersection. I can see that the first time period is going to be when t, in this case on the calculator obviously it's x, but on our problem it's t, is 0.92 hours. So it's an interval, so between t equals 0.92 hours and we're talking about hours after midnight. So we're like barely 1 a.m. If I do the whole process again, I'm going to move my cursor over to that second point of intersection and press enter 3 times. And I can find that that point is at 5.28 if I round. Okay, so it's maybe 5:15 in the morning. There's another time interval though, so I'm going to include that too, in between. And if we do it all over again, the second one, I'm just going to move over to that third point of intersection. And we get 13.49. And then the last one I'm just going to go ahead and give you is 17.85 hours. Okay. In number 24, it says the number of hours of daylight, and that's your function d of t, at a particular time of year in San Diego, California, can be approximated by the function d of t, where t is measured in days and t equals 1 corresponds to January 1st. So notice that we're talking about the time of year and we're measuring t in days. So if you think about an appropriate domain, when you're thinking about graphing this function, I want my x values to go from 0, and if I think about measuring in days and I'm dealing with a year, I want it to go to 365 days. And so this is another one I'm ultimately going to need to graph, so I'll go ahead and plug this into my calculator. So let me clear out what's in there. We're going to have 9 times the sine of 0.017 times x minus 1.53 plus 10. Okay, so this time we set our window, we need to make x go from 0 to 365. If you don't change your window settings, then you're not going to see a curve. Sometimes you're just going to see a straight line. So you do need to make sure you change your window settings. In terms of my y max, well, if you think about it, how many hours are there in a day? There's only 24 hours, so the most daylight there could possibly be is 24. And so if I make that my y max, this is the graph I should see. Okay, So in question A, it says, what day during the year has the most daylight in San Diego? And how much daylight is there on this day? So if I'm looking for the most daylight, I'm looking for the maximum. So choose your second calc. We're going to choose option 4 since that's the maximum. And do remember, though, when we're doing maximum and minimums, we have to choose left and right bounds. We can't just press enter 3 times. It's kind of annoying. Okay, so our maximum, the x value, 182.4, that gives us the day number. So this is going to be on day 182.4, and there are 19 hours of sun. It must be nice living in San Diego. Another way you could have figured out the maximum number of hours is basically, if you look at your equation, we know 10 is our midline and 9 is our amplitude. So if we add 9 plus 10, that's going to give us 19 hours. All right, in letter B, it says, on which days will there be an equal amount of sun and no sun? Well, if there's only 24 hours in a day, if there's an equal amount of sun and no sun, then we're talking about letting the number of hours of daylight, I guess I can just call that D, letting D equal 12, because that'll basically break the day in two. So if we let D equal 12, that's going to be a second equation. So to answer this question, it's just saying on what days are there exactly the same amount of sun as no sun. So I'm just finding the points of intersection. So I'll do it for the one, and then I'll just give you the answer for the other. So the first day that occurs is day 103.18. I'll just go ahead and say 0.2. The other, you have to do the whole process all over again, is on day 261.6. Okay, and then letter C, it says give an interval now for the days when the number of hours of sunlight is over 14. So if we look at the calculator, if we look at our graph, this time I'm changing my second equation to 14. And now I want an interval, so where it's going to be between 2 days. And so again, when we use the calc trace intersect, actually let me move closer to the first point of intersection. So the first day is going to be 117.09. And then the second one, if we do the whole process over again, we get, whoops, 247.7. Almost done, guys. Problem number 25. This is a Ferris wheel problem. We're told that a Ferris wheel is 368 feet in diameter and it makes one revolution every 422 seconds. So the 422, that's your period. The center of the wheel is 400 feet above the ground. So if you think about, here's my Ferris wheel. So if this is 400 feet above the ground and my Ferris wheel is basically going around and around and around, the 400 feet above ground is going to be my K value. That's going to be my midline. And the amplitude, so basically if this is the center, the amplitude is going to be half of the diameter. So that's going to be from the midline to the min or from the midline to the max. And so it's going to be half of 368. So A is going to be 368 over 2, and that gives me 184 feet. So that's going to be my A value. Okay, and so in part B it says, what's the maximum height above ground, and then how long will it take passengers to get to the maximum height? Well, if you think about it, if I know the midline and I know my amplitude, I should be able to figure out the maximum. The maximum height is just going to be my midline plus the amplitude. Well, we said the midline was 400 and my amplitude was 184. Remember, it's always positive. That gives me a max of 584 feet. Well, how long does it take to get there? Well, if I'm starting at the bottom of this thing and I want to know how long it takes to get to the top, well, that's just halfway. So if I take half of my period, I get 211 seconds. So I don't even actually need the equation to figure those out. In part C, how long will it take passengers to reach a height of 400 feet above ground for the first time? Well, again, if I'm starting down here and this is 400 feet, if I'm getting there for the first time, that's just a quarter of the way around the Ferris wheel. And so if I take a quarter of my period, that's going to leave me with 105.5 seconds. And again, it wasn't really necessary to use our model to answer these questions. Now, I will point out that using logic and using the model can sometimes produce different answers. So for example, let me show you what would happen if I actually used the calculator to come up with the answer to part C. So if I plug this equation into my calculator, so if we have negative 184 times the cosine of 0.015, and then I add 400. And if I think about my window, I want my x max to correspond with a period, which is 422. And my y max, we already said that the maximum height was 584. So I'm just going to say 600 feet is my max. What did I do? And I know this happens to you guys all the time, so this is probably good that it happened to me. And if you look at my equation, what did I forget? I forgot to put a t, and I notice now that I'm looking at the guide, I even forgot to put it in the guide. So there should be a t right here. So I apologize for that if that was confusing to anybody. That was a typo on the document itself, and obviously caused me to make a mistake when I graphed it. Okay, so once I fix that, I can see I'm going up and then coming back down. And I'm trying to figure out how long it takes to reach a height of 400 feet above ground for the first time. So since 400 is a height, I'm going to type that into another equation. And so again, we go up, we come down, and then there's my 400 feet, and I want to know how long it takes to get there for the first time. Now, just thinking logically, if I know that this thing takes 422 seconds to go all the way around, then if I want to figure out how long it takes to get a quarter of the way around, I should be able to multiply by 1/4. And so the correct answer should be 105.5 seconds. But if I use my model and I look for that first point of intersection, that means I'm going to have to move my cursor a little bit closer to that point. You may find that the value you get using your model is slightly different. And I really want to make sure that that point comes home. So using the model, it ends up being 104.7 seconds. And remember, the model is not going to be exact. It's just a model. So the values that we get when we use the model to make predictions aren't necessarily going to match what we see in reality. Hopefully it's close. If it's a good model, the values should be pretty close, but the model may be off a little bit. So there is a problem on the unit test that requires you to use the model, and I underlined it for you just to point that out. Because if you think logically through the problem, you'll get a different answer. So just note in the test, if it asks you to use the model, that you actually use the model, meaning you plug it into your calculator and use your calculator to solve it. If it doesn't specify that you need to use the model, or if there's not a model, then simply use logic to answer the questions like we did in parts B and C. Okay, in number 26, this is another example where we have a model. It says a company that produces baseball gloves forecasts monthly sales for 1 year to be S of T, where S is the sales in thousands of gloves and T is the time in months. So again, if we're looking at 1 year and time is measured in months, then my domain is going to go from 0 to 12 months. And with this problem, we absolutely need to use the equation in our calculator to solve at least B and C. If I want to know the months when it's the maximum and minimum, I'm also going to need to use the calculator. I can figure out the maximum and minimum sales by adding the amplitude to the midline, but I don't know what the t value will be at those points. So I actually need to use the graph for all of these equations, or for all of these questions. So let's go into y equals. Let me clear out what's in there and type in 62.8. Now notice that that 62.8 is in front. I cannot just add that to the 38.5 because I'd have to deal with the multiplication first with the sign. But that 62.8 is my midline. It is the average. Okay, and so then we've got pi times t divided by 6 minus 2. And I think that's it. And we also said that we want to go, since t is measured in months, we want to go from 0 to 12. And if I think about my y max, 38.5 plus 62.8, my y max, let's just go ahead and say that it's about 110. And that should hopefully. And this gives me the sales of baseball gloves in 1 year. And so it says to determine the months of maximum and minimum sales. Well, I can see that the minimum sales are over in the over to the left of my graph, so I'm going to do that first. So if I choose my minimum, that's option 3. And I'm going to have to move my cursor way, way, way close to my origin, or way close to where x is equal to 0 in order to do this. So my minimum, and you can see my y values are starting to go up, and then my left or my right bound. Okay. And so the minimum occurs when x is 0.82, I guess. So that's going to be month 0.82. So the minimum would be month 0.82. Okay, and then the maximum, if I wanted to do the maximum, I'm going to just do second trace, choose the maximum option, and do the same thing. I'm not going to go through this because we've done that for another problem, but the maximum value should be month, and it should be 6.82, I believe. Okay. In letter B, it says how many baseball gloves were sold in month 4. Well, this time, month 4, that's an x value, or in this case, a t value. If t is equal to 4, you can actually just plug the 4 into the equation and type it into your home screen. Or if you go to the second trace option, notice that the very first menu option is a value. This is where you can type in values of x. So if I plug in the 4, it'll give me the corresponding y value of 66.43. Now you do need to remember the correct unit, 66.43. It's not just gloves, it's actually thousands of gloves. Okay. And then in part C, it says, during what months does the company sell less than 56,000 gloves? So if I go back to my calculator, 56,000 gloves is a y value, or in this case, an s value. I'm not going to enter in all of the zeros. I'm just going to enter in the 56, and I can see where it intersects. And since I'm looking to see where the graph falls below this line, my interval is actually a disjunction. So when I find the points of intersection, the first one is basically an x value of 3.48. So anything before that month. So before month 3.48, so we're looking at like halfway through March. And then the other part of the solution would be after the other intersection point. And that would be month 10.16. Okay. And that's a disjunction, so we'd use the word or. Now, another question that's going to be asked of you is to figure out the total sales for the year. And there are a couple different ways that you can do this. I can figure out the total sales in January by plugging in t equals 1 and getting a y value. I could do it for February by plugging in 2, for March by plugging in 3, and then adding up all those values. An easier way to do this, and I'm putting this on here because there is a question like this on the test. So to find the total sales for the year, and this is just an estimate. Well, you got to think. T is measured in months, and there are 12 months in the year. So if I take 12, I can actually multiply that by my average sales. And where is average sales located in the equation? If you look back, the average sales is going to correspond to our midline of 62.8. So if that's the average I sell every single month, and if I multiply that by 12, that's actually going to give me the total sales for the year, or at least an approximation. And so that's going to give me approximately 753.6 thousand gloves. That's how much they can estimate that they will sell in a year, according to this model. Okay, so I'm putting that as a big star because there is a problem like that on the unit test, and there wasn't an example on your review. All right, 2 more problems. These correspond to your identities. So notice that I have the identities on the top of the page for you. In number 27, it says to use the identities to simplify the expression into a single trig function. So there are lots of different ways that you can simplify these expressions. One of the things that I first look for is if there's an addition or subtraction, because usually if there's addition and subtraction, I'm going to be using a Pythagorean identity eventually. But if I look at, like, for example, 27, there's no identity that looks like this. So I'm kind of stuck. What I do notice, though, is I'm subtracting 2 quantities that both involve cosine. So one of the things that I might do is think about what would happen if I factor that cosine out. And so if I factor the cosine of theta out, I'm basically dividing it out of both terms. So that's going to leave me with 1 minus, because cosine divided by cosine is just 1, and if I divide it out of the second quantity, that's going to leave me with the sine squared of theta. Now let's look and see if that matches any of our trig identities. 1 minus sine squared of theta actually looks just like the cosine squared. So I'm going to replace that quantity with cosine squared theta. And then I'm just going to bring down the other cosines of theta. And so if I have cosine of theta times cosine squared of theta, that's just like if I was taking x times x squared, it's going to become cosine cubed of theta. And that would be your final answer. And there may be other ways of simplifying this. I can't think of them right now, but certainly if you have simplified it in a different way and you want me to check to make sure it works, I will certainly do that for you. In number 28, when you're ever asked to verify an identity, it's kind of confusing because when you look at it, it looks like an equation. And it looks like, you know, whatever we've done with equations before, we've figured out the value of the variable. But that's not what these problems are asking you to do. The difference between what we did in 27 and 28 is that now you have a destination. So in 27, I didn't know where I was going. I was just rewriting this thing, hoping that I'd somehow limit it down to one function. In 28, you're actually given a destination. You're given a start and you're given an end. So this is my starting quantity. And basically what I'm going to do is I'm going to manipulate it and manipulate it and manipulate it until I end up with 1 over the cosecant squared of theta. So if you think about what 1 minus the cosine squared of theta is, that looks like a trig identity to me. I see the subtraction, I see the 1 minus the cosine squared, and when I look up at my identities, I can see that that corresponds to the sine squared of theta. So I'm actually going to rewrite this quantity as the sine squared of theta. Well, now I don't need my trig identities. Now I need to think about my basic identities. And usually we don't write the sine as anything else. We usually transform everything into sine and cosine. But this is an example of when I might want to write sine in a different way. And if you remember, the sine is just the reciprocal of the cosecant. And so at this point, I can just rewrite this as 1 over the cosecant squared. And that is exactly where I am supposed to end up. So I'm actually done. Now, with the trig identities, it takes a lot of practice to kind of see the different patterns that work. So one of the things, if you think you might need some extra practice, section 14.1 in the book will give you some more practice. Some of them are easier than others, some of them are more difficult, but you each should have 2 workbooks at home in addition to the textbook. So that should be plenty of extra practice. The answer to the odd numbered problems in the text are in the back of the book, and certainly you can come in for Bulldog Block if you need extra help. Please understand that because the test is going to take the entire period, we will not spend any time in class going over this review. So if you have any questions about anything that I've gone over, you need to come in for Bulldog Block. I hope this was helpful.